Did you know that the discovery of black holes is actually relatively recent? That's right. We're all too familiar with the concept of black holes now, but that wasn't always the case. The first black hole was actually discovered by researchers in 1974, and it happened by complete accident. Astronomers uncovered the motion of hot, swirling forms of gas and dust in space called disks. Scientists realized these disks were likely the result of a large amount of gravitational mass. Astronomers called the first black hole Cygnus X1, and it actually took over 30 years for researchers to agree that Cygnus X1 was an actual black hole and not some random space anomaly. You might wonder, how does a black hole even form in the first place? A black hole is born when a massive star, at least 20 times the size of the Sun, exhausts its nuclear fuel, such as hydrogen. Without this fuel to sustain the intense pressure and heat, often reaching millions of degrees, the star can no longer counteract the force of gravity. As a result, it collapses in on itself, triggering the formation of a black hole. Once formed, the black hole's immense gravitational pull draws in surrounding mass, consuming everything that crosses its event horizon. Instead of becoming a white dwarf like smaller stars typically do, a massive star undergoes a violent and complete sequence of events that ultimately leads to the formation of a black hole. After the core of the Sun runs out of nuclear fuel, it can no longer be held up by gravity. The outer layer will begin to collapse inwards and create a supernova after all the mass is released into space in fragments. Black holes actually do not form instantaneously after the supernova occurs. It may actually take a few seconds or over 1 million years for the black hole to form, but the time will usually depend on how massive the star was before its transformation. After the supernova occurs, it's basically just the remnants of the collapsed star, which ironically is a very beautiful and luminous image in space. A supernova can actually become so luminous it can light up the entire galaxy. Unfortunately, the supernova does not last forever, and eventually it will become a black hole. That is, if the mass of the star before was at least 3 times larger than the Sun. In the span of a few seconds or at least a few million years, it will continue to collapse and shrink, but increase in density or weight. Then a process called gravitational singularity will occur, which is when gravity is so strong that space-time breaks down itself, and the supernova eventually becomes a black hole. At the heart of a black hole lies a gravitational singularity. While the singularity remains purely theoretical, as no one has ever observed one firsthand, scientists believe that within this region, the laws of physics as we know them break down. This extreme gravitational pull is what makes black holes so fascinating and terrifying. Their immense gravity is so powerful that not even light can escape, which is why we often imagine being pulled impossibly into their depths. Another question you might have is, how are black holes detected in the first place if they don't emit light? Well, we can't in the traditional sense, but we can still see their effect on the surrounding objects in space. For example, the black hole has an immense amount of gravity. So if an astronomer sees a star orbiting around something incredibly massive but invisible, the gravitational influence of the black hole itself can be identified. So the astronomer might study the motion of the star's orbit and speed and estimate the mass of the unknown object, which then can point to the existence of a black hole. Telescopes can also be used to identify the effects of black holes. Where gas or dust falls from a black hole, they can actually form a bright, hot, and swirling disk in space called an accretion disk. As matter spirals inward, the temperature rises exponentially, and it can cause radio waves or X-rays, which are waves of high energy in space-time that are able to pass through objects like black holes which are not able to emit light. One of the most interesting theories about black holes is what happens to space and time when near a black hole. Time might slow down, and a process called gravitational time dilation occurs, which means time may move more slowly than it normally would when you are near a massive object in space-time. The stronger a gravitational field may be, the slower time becomes. There is a part of the black hole known as the event horizon, a theoretical area surrounding the black hole where absolutely no light or radiation may escape. Let's say you are watching somebody fall into a black hole. From your point of view, the person approaching the event horizon would move in slow movements and eventually freeze in time. But they wouldn't notice this, just you, the outside observer. Space itself will become distorted, causing objects to stretch and appear warped. Objects approaching a black hole experience extreme tidal forces, intense gravitational differences that stretch and distort them. This dramatic effect, known as spaghettification, occurs because the gravitational pull on the object's closer side is significantly stronger than on the farther side, stretching it into a long, thin shape, much like a strand of spaghetti. Black holes are among some of the most mysterious objects in the universe, and a lot of the research on them is considered highly theoretical. Though they are seen as these undetectable and unknowable forces, they are very real, and we can still detect them from the effect they have on the surrounding universe. They are crucial in understanding how the universe works and the interactions of the surrounding celestial objects. They challenge our understanding of how space and physics work, and show us that there are things in our universe that we are not always able to fully understand, or ever understand. Thanks for watching. Be sure to let us know what you think by liking the video.
Hey there! You know those great videos that you've been watching on both of our shows, 300 Seconds of Science and 5-Minute Flashback? Well, we've decided to join forces and make a brand new channel called Smart Cookies. Don't worry, we're still going to make those same awesome videos that you're used to on the channel, they just might look a little different. It'll be the new place to watch some of our best videos that we've yet to offer. We'll see you there on March 14th.
This program was produced by ZTV at the University of Akron. Do you want to gain experience in video production, professional social media, or working with real clients? Visit the UA School of Communications online or follow us on social media to learn more. ZTV, make media, make a difference.